So what does covalent bond mean and how a covalent bond is formed between two atoms? And students, do remember that as we have discussed in case of ionic bonding, that only metal and non-metal can undergo the formation of ionic bonding. In the same way, covalent bond can be formed only between two atoms when they are non-metals. Now we have to discuss about covalency. So covalency is defined as the number of electrons of an atom mutually shared during covalent bonding. So let's see that how we can determine the covalency during covalent bonding between two atoms. So let us consider an example of bonding between two oxygen atoms in O2 molecule. Now in O2 molecule, we have got two oxygen atom, and already we have discussed in the last section that during bonding only the valence shell electron participates. So the valence shell electron in case of oxygen will be equal to 6, that is 2 electrons will be present in the 2s orbital and 4 electrons are present in 2p. So we can write it as 1, 2, 3, 4, 5, 6. Similarly, in case of another oxygen atom, we shall be having 6 electron, 2, 3, 4, 5, 6. Now bonding is just to complete the octet, that is 8 electrons in the valence shell, that is NH2 NP6 configuration. So both these oxygen atoms are lacking 2 electrons, hence for completing their octet both will undergo mutual sharing of 2 electrons. That means this oxygen atom will share 2 of electrons of the first O atom. Similarly, first O atom will share 2 electrons of the second O atom. Now what we are observing here is that the two oxygen atoms are undergoing mutual sharing of 2 electrons. So the same can be represented as O, double bond O, and after that we are finding that 4 electrons of both the oxygen atoms are not participating in the bonding. Now what we are observing here is that during bonding or covalent bonding between these two O atoms, 2 electrons of both the oxygen atoms are undergoing mutual sharing. So in this case, the covalency will be equal to 2. Means basically to determine covalency, we have to judge out that the bonding atoms must undergo mutual sharing of electron, and based on the number of mutual sharing of electron, we can determine covalency. Let's move to another example. Let's discuss about the bonding between hydrogen and chlorine. Now in case of hydrogen, we have got 1 electron, whereas in case of chlorine, we have got 7 electron in its valence shell. Now hydrogen, to stabilize, will try to attain configuration similar to that of helium, that is it will try to have 2 electrons. So hydrogen will share 1 electron of chlorine, making its configuration similar to that of helium and hence stabilizing it. Similarly, chlorine will also undergo the sharing of 1 electron of hydrogen because it has got 7 electrons in the valence shell. So to complete the octet, it will try to have 8 electrons, that is 1 electron will be shared by hydrogen atom for the completion of octet of chlorine atom. Now student, we are observing that both hydrogen and chlorine are undergoing mutual sharing of 1 electron. So here we can represent the molecule as H, then we will be having a single bond, then chlorine. Why we are using a single bond here? Because 1 electrons are being mutually shared between both these atoms. So if we have to calculate the covalency, then in this case the covalency will be equal to 1. Why we are saying the covalency will be equal to 1? Because both these atoms are undergoing mutual sharing of 1 electron. After the bonding between these two atoms, we are finding that the rest 6 electrons in the valence shell of chlorine are not undergoing mutual sharing, or they are not participating in the bonding. Here we have got 6 electrons in the valence shell of chlorine which are not participating in the bonding. Now remember, a pair of electron in the valence shell of an atom which does not participate in the bonding, that is called a lone pair. We shall be calling it as a lone pair. Again, we are repeating it, that whenever a pair of electron from the valence shell of an atom does not participate in the bonding, then in that case we shall be calling it as a lone pair. So we can define it as the pair of electrons from the valence shell of an atom which does not participate in the bonding is called a lone pair. So this is how we can calculate the covalency during covalent bonding between two non-metallic atoms. Let's switch over to another example too. Suppose we have to find out the covalency when two nitrogen atoms are undergoing covalent bonding to form a nitrogen, that is N2 molecule. So here nitrogen has an atomic number of 7. So if we write the configuration, it will be 1s2, 2s2, 2p3. Means the valence shell of nitrogen has got 2s2, 2p3. That is, it has got 5 electrons in valence shell. Now, to complete the octet, it requires 3 electrons. Means its octet is incomplete by 3 electrons. So let's check out the bonding between the two nitrogen atoms to form N2 molecule. So we have nitrogen which has got 5 electrons in the valence shell. So 1, 2, 3, 4, 5. Similarly, the other nitrogen atom has got 5 electron in the valence shell. Now for the completion of octet, the first nitrogen will share 3 electrons of the second nitrogen atom, while the second will also share 3 electrons of the first nitrogen atom. So by the mutual sharing of 3 electrons, we are observing that both the nitrogen atoms have completed their octet and hence now they are stable. So here we have got 3 electrons which are undergoing mutual sharing. So in this case, covalency will be equal to 3. Now if we represent the bond between the two nitrogen atom, it will be nitrogen, then triple bond, and then we have got again nitrogen. Now both the nitrogen atoms have got 2 electrons in their valence shell which are not participating in the bonding. As stated earlier, we have discussed that whenever a pair of electrons in the valence shell of an atom does not participate in the bonding, then in that case we call it as a lone pair. Means this will be lone pair. Similarly, this will be also a lone pair.